immense pleasure to welcome you all for this technical webinar. Today, the webinar is going to be presented by Dr. Mamilla Ravi Sankar from IIT Tirupati. He is Associate Professor in Mechanical Engineering and he has got widespread knowledge on cutting fluids in machining, whether it is a Boon or Bane. That is the topic he is going to talk today. So again, I welcome all the participants for this wonderful webinar. Any questions, any clarifications can be raised at the end of the webinar so that doctor will be in a position to give full clarification on that. So request all the participants to mute yourself till the end of the program. So before starting the presentation, I request our council member, Mr. Hema Prasad, to introduce Dr. Ravi Shankar to this August forum. Over to Hema Prasad.
Thank you, sir. It's my pleasure to introduce today's speaker, Dr. Mamilla Ravi Sankar. Dr. Mamilla Ravi Sankar is currently an associate professor in the Department of Mechanical Engineering at IIT Tirupati. He has served nearly 7 years as assistant professor in Department of Mechanical Engineering at IIT Guwahati before he joins in IIT Tirupati. He did his BTech from Sri Venkateswara University, Tirupati, and MTech as well as PhD from IIT Kanpur. His research group focuses on micro-nano manufacturing, sustainable manufacturing, precision 3D printing, online monitoring, biomanufacturing, coatings, tribology, and rheology. He has published over 55 in internationally reputed journals, 100 international conferences, 7 patents, 2 edited books, and 12 book chapters with H index of 23 as well as I10 index 60. Presently, his lab possesses with various funding from BARC, DST, DRDL, CERB, IGSTC, IIT Guwahati, IIT Tirupati of about 5.2 crore rupees as principal investigator and 160 crore rupees as co-investigator. He guided 5 PhD and 30 MTech as well as 35 BTech students. Currently, he is guiding 20 PhD and 7 MS research students. He is the editorial member for HIMEC e-Journal of Micro Manufacturing and guest editor for International Journal of Precision Technology. He is a recipient of prestigious awards such as Institute of Engineers India IEI Young Engineers Award in 2015 in Production Engineering, Indian Society for Advancement in Materials and Process Engineering in 2011, and finalist of Indian National Academy of Engineering Young Engineers Award 2014. Apart from academic awards, he has also received Institute Blues Outstanding Sports Personality of IIT Kanpur for the year 2009 for his outstanding games and sports achievements. Thank you. Over to Dr. Ravi Shankar, sir. Thank you.
Thank you, Professor, for introducing me. Can you able to see my screen?
Yeah, doctor. Yeah.
Yes, sir.
So I am audible as well as my slides are visible clearly.
Yes, sir.
Fine.
Yeah, thank you. Thank you for the introduction. Thank you, Ramanji, for giving the opportunity for presenting what we do. So we do some of the areas in the area of so we do most of the times in micro nano manufacturing and other things. One of the area that we work is sustainable machining, where we try to develop the green cutting fluids and we develop the cutting tools. So majorly, this is a one part of the PhD student who has done the work. Apart from it, also if there is any opportunity or something, then we can showcase at the later the stage. So currently, I'm going to talk on cutting fluids in machining of castings because many of you are from the castings, and so let me introduce about my lab. I'm not going to tell you in detail. I think there's some this is coming. Okay. So machining and micro machining, nano machining and other things, sustainable manufacturing, which I'm going to talk in this area, what we try to do. So Nano materials and manufacturing group, additive manufacturing and smart manufacturing, these are things that we try to do. So first comes why we have to do the machine operations castings. So as you are aware, as you are much experienced compared to me in area of castings, so whenever you want to make a near-net shape, so normally you require some of the post-processing. Okay, whenever the customer asks you to certain shapes, at the same time you need to remove a lot of material on the surface of the castings also. So you need to meet the near dimensions. Whenever you want to meet the near dimensions, automatically you are supposed to do some of the post casting techniques. So such as one of the major techniques that you can be using in your foundry, apart from foundry, I mean say that the auxiliary that you may have is normally the machining process. Okay, so the machining, so you take the casting process and you try to do the machining of this casting, so that what will happen, you just get the required dimensions of what the customer needs. Okay, during this process, so what is going to happen, for example, this type of large components, if you want to machine, and for example if you want to make some components, then you need to do the machining. So the most importantly, what I mean to say is that you remove some of the skin of the castings at the required locations and so on. So this may give you a lot of other technologies which the foundrymen may not be having that one. So is what I'm going to present is only the machining. Okay. So the manufacturing sector, for example, so if you see, listen to the monkey bath or other things of what the central government says. So we are very good at casting. We are very good at farming. We are very good at welding and so on. So our manufacturing sector GDP to the Indian, I mean say Indian GDP is approximately 17 to 18% or maybe plus or minus one. So I am guess it is less than 20%. So whenever you want to go to the GDP, like for example, if you take the GDP of China, it may be like 30 plus. So whenever we want to make ourselves to superpower, normally our manufacturing industry's GDP should be above 30%, or I mean to say 35% or something. So one of the things, thrust areas that we may require is micro nano manufacturing, which is lacking by the Indian industries and so on. Another one industry that you can think of is, from the environmental point of view, sustainable machining and sustainable manufacturing. If you see sustainable manufacturing, so the manufacturing industry accords almost all 60% of the waste. I mean to say, if you take waste, so this is exclusively because of the casting industries and machining industries, so on. So you need to make it more sustainable. And so what are the common post techniques that people uses after the casting process? So some of the processes that normally people will be using is like turning process. I mean to say lathe based, milling based. These are the varieties of the things that people try to use in the arena of the post casting technologies. Now you can see some of the other technologies is like tapping, drilling, so on. So our main motto presently here is how we can convert a casted component into a customer satisfied product. So in between, some of the process will come. So those may be, most of this may be the subtractive manufacturing. Subtractive manufacturing means top-down approach. Top-down approach does mean is that you have a big casting. So for example, this casting is there. and this is machined here. So for example, in this case, up to this, it might be filled. So later that, for example, simple way is, for example, I have a rod of 100 diameter and my customer requirement is 98 So what you do, you try to do the machining of 2 and you remove. So that is nothing but top down approach. You are taking a bigger one and you try to do the machining towards the requirement. So top-down approach. Additive manufacturing nowadays people talk about is bottom-up approach. So particle part by particle they will be adding on it. So in the machining process, so what are the basic problems comes? In the machining process, if you see, the cutting tool is interacting with respect to the workpiece, which is a casted component. This will have a lot of problems like heat in shearing zone, heat in chip tool interface, and so on. Just watch the video, you will understand what is the basic problem here. So this shows that temperature generation during the casting for products machining. For example, if some product is machining, in this case, for example, it is a casted cylinder. For example, if you are doing the machining operations, you can see the tool is severely affected. So a lot of temperature is generated here. When the temperature generated, if you are not going to use the cutting fluids here, so or any other source, so what will happen here is that a lot of particle generation will be there and operator may experience. Anyhow, that you can see in the shear zone. For example, I am cutting here, and if I take a shear zone, chip tool interface house, there are two regions. One is sticking zone, another one is sliding zone. So where the chip tool interaction will be severe, where the boundary lubrication is required, or and the sliding zone, normally mixed lubrication and so on will come into picture. So for example, if you take the high speed steel with respect to the mild steel, normally the temperature, the maximum temperature normally you will observe is approximately 700 degrees for a simple materials. So to counter this, what are the solutions? So the first solution is going for a super sophisticated cutting, which is not that much into the arena of Indian industries and so on. But the basic problem here is CBN tools or diamond tools or this type of tools are much expensive. Each one tool cost may be like 3,000 to 5,000 or more than 5,000. Some cases it will be from standard companies, it goes beyond 6,000 also. However, there is another alternative that can be like cutting fluids. So cutting fluids, for example, if you want to purchase 20 liters can, so that you may get from 1,500 to 2,500. So on top of it, this 20 liter, this 20 liters, what is you can mix with 1:10 ratio. So that means that almost all each 1 liter of your cutting fluid you can mix with respect to 10 liters of water. I mean to say approximately you will end up with 220 liters of cutting fluid with a money of almost all 1,500 to 2,000 rupees. So however, if you want to go with a cutting tool, which is a super sophisticated or something, one tool will cost you 4,000 to 6,000 rupees, which is expensive from the Indian market perspective. So if at all I want to produce a final product after casting. So people predominantly uses economic cutting tools, and most of the times they may also use some of the cutting fluids because they want to stay in the market. So this is the normal trend in Indian scenario of the machining industries to have the best profits. I mean to say best the selling price to the base price or something. For example, why the people uses cutting fluid? Cutting fluid reduces the friction and wear, it reduces the temperature and distortion and washes away the chips, prevent corrosion and reduces the force, energy consumption, so on. These are the multiple varieties of cutting fluid functions are there. Okay. So at the same time, cutting fluid accords approximately 15 to 17% of product cost. This is not from the casting perspective, this is from the machining perspective. For example, there is no casted component. You have given a rod from where somebody has to develop a product out of it. In a machining industry, so normally the product cost is accounted for the cutting fluid from 15 to 17% of that one. So what type of cutting fluids normally available? So there are two prominent properties that one must look at. One is lubricating properties, another one is cooling properties. On x-axis you can see lubricating properties, on y-axis you can see cooling properties. So first we will see on the x-axis. For example, I want the lubricating properties predominantly. What we try to do is we try to use mineral oil. For example, if you see the farming processes like extrusion and so on, so sheet metal bending or some of the incremental farming and so on, where you don't use any water-based cutting fluids or something, where you directly use the lubricants that you can get from the industry. Okay, on other case, predominantly cooling properties are required. So let me tell you when these cutting fluids are required. For example, if somebody want to do the machining of hard materials, first hard machining. So there you normally operate your machining conditions at very low cutting speed, low feed, low depth of cut. In that circumstances, most of the time you require lubrication or friction is the dominating factor. So that's why you try to go for lubricating characteristics, that is called mineral oil or mineral oil with additives. In others way, high speed machining is there. In high speed machining, you try to use high cutting speeds, slightly moderate depth of cut as well as feed and so on. In that circumstances, what is the best thing is you will experience lot of temperature. If you want to remove that by virtue of convective heat transfer, so water is the best convective heat transfer coefficient material that can extract. However, in most of the cases, the people try to use mix of these things. So they will mix the cutting fluid with respect to water to account for better lubricating properties as well as better cooling properties. This is what the industry always looks at. So that is called emulsions. Okay. So what are these emulsions and other things we will be seeing in upcoming slides. So emulsions and emulsion additives basically. So you require a lot of additives. So cutting fluids. Cutting fluids will have lot of additives like emulsifiers, biocides, rust inhibitors, anti-wear additives, extreme pressure additives, anti-foam additives, pH regulators, and so on. You name many things are there. The most important thing that one has to know here is that most of the companies that supply the cutting fluid will have inbuilt all these things. Okay, so when you inbuilt all these things, you may be thinking why I require all these things. But the requirement of person to person may vary. For example, if you have ANSI software, so you should write your own subroutines because your requirement is completely different from some other's requirement. Somebody may like curd rice, you may like sambar rice. So doesn't so as per the requirement of you, you should play with these additives, even though some of the common things are inbuilt in this particular cutting fluids. So the first and foremost one is that additive that you have to look at is emulsifiers. Emulsifiers are the substances are this major function of the emulsifier is to reduce the surface tension between two immiscible fluids. For example, you have the water where you just put some drops of coconut oil. What will happen? So both will not mix because the surface tension of the coconut oil is completely different from the water. In that circumstances, you need to add some emulsifiers which makes the surface tension between these two approximately equal. When the surface tension between these two is approximately equal, what will happen? So this will dissipate or this will fragmentize into the small fragments. So now how this will happen? So emulsifiers will have polar head and non-polar tail. So here emulsifier, you can see two circles. These two circles are not the emulsifier. One sky blue color emulsifier is a, I mean to say circle is a water, and another yellow color is the oil. In this between two, there is a hexagon as well as there is a triangular shapes. So this is one is polar head and non-polar tail. This will connect the water and oil and how it will be doing. There are polar molecules, non-polar molecules and so on. How the mechanism works here. For example, you have the water and you have the oil. So these two are immiscible. When you add emulsifier you have seen polar head and non-polar tail. So polar head will be in water and non-polar tail will be in the oil. So when you have the independency of the energy and so on, or you can have the agitation and so on, what will happen? Here each head of the, I mean to say polar head, try to move into the water. When it try to move into the water, this will happen. For example, you see all these particles, heads, all the heads want to swim away because they have a lot of energy in it. So during this course of action, what will happen? So the oil particulates will travel or will fragment and move away. So because of this, what will happen is you can see this emulsion formation. Now, simple example, whenever you just go for a urine, so you can sometimes you just see yellow color. It is nothing that you have yellow color or it is not in yellow color. Basically, there are some particulate materials which are coming out from your body, which makes the refraction of in the yellow color and so on. So, for example, in this way, these small fragments of the emulsions will make certain colors into this one. So now you can see here water in oil emulsions, oil in water emulsions, and micro emulsions, and so on. For example, water in oil emulsions, so where water will be the minor and oil will be the major. For example, if you can see here, so always what I'm representing here is sky blue color says always a water and yellow color is always an oil. Okay, so you can see here how the things works. Always your head will be inside the water and this will try to pull. So simple mechanism here is that your polar head will try to pull and these polar heads are all away, all around 360 degrees. If all 360 degrees it will pulls, what will happen? Fragments of oil molecules will segregate and forms the particulates or fragments. Okay, so whenever you see the practically how these emulsions look like is like this. Okay, so next one is extreme pressure additives. Extreme pressure additives means when there is a high pressure, for example. So whenever you are doing the casting product, the chip will be moving on the cutting tool. When the chip is moving on the cutting tool, what will happen? Lot of pressure will be there. So this may lead to the tool wear, and then after some time there will be a catastrophic failure of the cutting tool. To overcome that, so you add some extreme pressure additives, because of which what will happen? This cutting fluid forms a protective layer on the cutting tool. So always this will act as a sacrificial layer. So as soon as the chip comes, because your cutting fluid is continuously falling, so immediately it tries to develop the sacrificial layer, and when the tool interacts with respect to chip, the chip will takes away the sacrificial layer, which is a extreme pressure additive layer, and such the cutting tool will be protected. Okay, so anti-foam additives. For example, if you have the machining process is going on and there will be a lot of foam generation, so there will be a lot of ambiguity, and most importantly there will be a chemical reaction and so on. So you need to try to avoid this anti-foam. Because of that, what we try to use is normally hydrophobic silica type of nanoparticles and such things people normally uses. So whenever it is interacts with respect to the bubbles that is generated or the foam that is generated, what will happen? It will blast, and it will make the clarity in the machining zone and so on. Biocides. Biocides is one of the most important one that one has to use in the cutting fluid, because industry always looks at how we can retain the cutting fluid for longer durations. When you want to have a longer durations, for example, if you are going to keep your cutting fluid for month time, for example, if you see 1 liter of cutting, I mean to say lubricant is mixed with 10 liters of water. So do you drink a water after 3 days or 4 days? No, obviously you don't drink it. Okay. So because it will be not of good quality. So that means that you are adding 1 liter of cutting fluid to 10 liters of water. You are using it per month or 2 months or 3 months. In that circumstances, what you need to take is you need to take care of these particular things from gram negative bacteria, gram positive bacteria, fungal virus, and many microbes. For that purpose, you try to have the biocides. Biocides will prevent this biological organs, I mean say organisms development on these particular fluids. So another one is you also want anti-rusting additives, because as I said earlier, we are using 1 is to 10 liters. I mean to say 1 liter of cutting fluid to 10 liters of water. When the water will fall on the machining process of the casting, so your casting is iron based. I mean to say like mild steel based or cast iron based or so many. So this will make the casting rusted. To overcome that, normally what we try to do is you try to have some anti-rusting additives which forms on the final product. For example, if you see here in the first one, barrier protection, so there will be a small nano micro layer will form where water molecules will, whenever you interact, it will stay on the top and it will not going to attack the material that you are going to machine. Okay, so these are about the positives. For example, what I mean to say, you have till now you have seen advantages. So cutting fluids are required because a lot of temperature generates, which may hamper the microstructure of your castings. If you don't use, if there is a severe machining operation, then there will be a burning on the these things. If at all to overcome all these things, you have to use very costly cutting tools, which is not of your bread and butter because it will escalate the cost of your castings. So your customer may not be liking, and for which you have to use the cutting fluids, and cutting fluids will have emulsifiers, biocides, extreme pressure additives, anti-rusting additives, so on, like foam, anti-foam, and so on. Till now, we have seen this is the positive side of the cutting tool. I mean, say cutting fluids. So now we will see what are the precautions. So you cannot avoid these cutting fluids, but how this is going to affect you. So you may be an engineer in a casting industry where the machining is a prominent one. So you should be aware of how to protect your staff, because protecting our staff is utmost important, because if they die, what about their families? It is nearly unimaginable. Okay. So for a company, it may be good. You may be happy that if he dies, his son will come. If he dies, his grandson will come. Great grandson will come. From the company point of view, maybe, may not be. But what about the family? Family will be on the roads. So, as an engineer, at most important thing is that you should take care of your company by giving the good profits. At the same time, it is your responsibility to protect your operators, because somebody is waiting at their home. Okay, so to know that, we will be looking at what are these chemicals that are there available in this one, and how this will hamper the operators. So International Agency for Research on Cancer has conducted that sufficient evidence on material. So what will happen whenever you try to do the machining operation or any other operation where cutting fluids are involved? Just watch the video for a moment. In this video, we are dropping the cutting fluid drop by drop, and sometimes we drop more also in the machining zone to demonstrate what is really happening at the dropwise level. Just we are dropping, you can see that droplet is coming from the top. When the droplet falls, so I am only speaking this because this is my MTech project actually, which I did at IIT Kanpur. So obviously you can listen that Hindi, which I am speaking little bit of Hindi. Okay. So when such emissions are coming, where it goes, first and foremost is the system. System means operator and adjacent operators. So you are bending in a lathe process. Normally you bend and you just do the operation. So you are welcoming these emissions through your nose. If you are talking, through the mouth, and otherwise you can also splash this cutting fluid on your skin. Okay, so let me see what these things will happen. So these are the chemicals. I will go by one chemical, and this one by one chemical causes this type of severe diseases which nobody can avoid. Okay, so the first emission is chlorinated paraffins. So what are chlorinated paraffins? Chlorinated paraffins are organic chlorine containing substances. That means that if you know the carbon compounds, there are three varieties: alkanes, alkenes, and alkynes. In the alkanes, CnH2n plus 2, so CnH2n plus 1 and chlorine will be there. Okay, or CnH2n and 2 chlorines will be there. So this will be normally available on synthetic oils and straight oils. Okay, so there are three varieties of this one: small chain, intermediate chain, and long chains. What will happen to this is that whenever this falls in the vicinity of the machining process, because of that, this will emit, I mean to say, this synthetic oils or straight oils will emit the chlorinated paraffins whenever it is exposed to the machining process. So this, the first one is contact dermatitis. So your cutting fluid falls in the machining zone. This machining zone, assume that the turning operation is going on. So your headstock is rotating. That means that your workpiece is rotating at 1000 RPM or 2000 RPM. The first time cutting fluid goes, and some cutting fluid takes part in the machining zone, and some cutting fluid goes to the cutting fluid tank, which is beneath the lathe machine. So what will happen? Contaminated cutting fluid will be there along with the virgin fluid. So this again comes, again comes, again comes. What will happen? Whenever it is rotating the workpiece, it will splash on your body, it will splash on your hands, and so on. This will lead to contact dermatitis. Okay, there are 6 layers of your skin. The outermost layer is epidermis and outer dermis. These two things will be completely affected by the contact dermatitis. Okay, so this will be like an allergy process. So apart from it, you can see here, since there is a chlorine content, chlorinac will comes and folliculitis. So folliculitis I will be explaining you in a better way in the next slides, because most of the operators are male people. Just we will see here, and thyroid and liver cancers also. Okay, so hair folliculitis. For example, you are an operator, you are doing it, and whenever this splashing will takes place, I mean to say the cutting fluid falls on your head. So by the virtue of gravity, this cutting fluid, whichever it fall on your hair or on your chin also, will try to go and occupy the pores where your hair is formed. Wherever it occupies, their hair will not grow. So improper growth of hair is nothing but folliculitis. So this other one is only allergy oriented, partial cancer oriented, and chlorinac oriented, and other things will be the chlorinated paraffins. You go to another one, which is most dangerous, is PAH, polyaromatic hydrocarbons. Polyaromatic hydrocarbons, one of the things that is presented is mineral oils is benzoyapyrene. Okay, so benzoyapyrene, normally, for example, if you see here, it is enters through any part of your body. It may enter through the nose, it can enter through the mouth, it can enter through the skin, it can enter through any part of your body. So what it will do? It will
जसं
first,
आता 25 स्क्वेअर एम चा अल्युमिनियम लक्स लिहिले आहे 24 वेगवेगळे त्यांना एका ह्याच्यात लिहून आणून द्यायचं सर.
okay. So benzoyapyrene, whenever it enters, what will happen? Your body is abundant amount of oxygen as well as abundant amount of water. So it will interact with respect to the oxygen, water, oxygen, so on, and it forms a carcinogenic material. Okay, so how this carcinogenic material try to go and occupy the DNA of your cells. For example, you have the biological cells in your body. So these biological cells will be controlled by the DNA, or you can say the nucleus of. So it will goes and binds to the DNA of the cell. if you it binds to the DNA of the cell, what will happen? Cell loses its control and cell proliferation will be uncontrollable, which is nothing but the mutations. Okay, so these mutations will causes the cancer, or uncontrolled growth of the cells is nothing but the cancer. Third and fourth is, these are the two major things. One is chlorinated paraffins, another one is polyaromatic hydrocarbons. So other things is nitrosamines and nitrates. Nitrosamines results in the alkylamides, which are, since you are using emulsifiers, you should be bit careful about how much emulsifier should be there in the cutting fluid. Some of the companies may not follow the rules and regulations. Normally, 80% of the nitrosamines are N-nitrosamines, potentially carcinogenic. Okay, so this, for example, if you are looking at the nitrosamines quantity, it should be like 50 micrograms of nitrates per gram of cutting fluid. If it is your responsibility as an engineer to check the cutting fluid that you are bringing and giving to the operators. In case if it is more than 50 micrograms, you should be alert. Next one is nitrates. Nitrates normally will be the component of corrosion inhibitors, anti-rusting agents and other things. At the same time, you are using the biocides also to prevent for longer duration. Because of that, what will happen here is that these nitrates will come. These nitrates will cause again the cancer. So endotoxins. Endotoxins is produced by the gram-negative organisms or bacteria when the cutting fluids are poorly maintained. That means that you are using the cutting fluid again, and again. Which is a normal trend in most of the Indian industries, until unless this cutting fluid will become from white color to the brown color. So in that condition, you are not properly maintaining. Because of that, what will happen? So outer cell of gram-negative bacteria will comes out and causes chronic inflammation, which is one of the prominently available, prominently visible thing among the most of the operators is shortness of the breath, wheezing, chest tightness, and so on. I mean to say, it is like asthma and so on. So cobalt is very peculiar in certain cases only. For example, if you are using tungsten carbide cutting tools and you are using the cutting fluid that consists of amine groups, in that circumstances, you may experience this problem because amines are going to attack the tungsten carbide or any type of carbides where you have the binders, cobalt binders. So whenever the cutting tool of tungsten carbide is made, there will be binders, which is cobalt. So you do the powder metallurgy, then you try to sinter it to make the cutting tool. And it is like a building blocks of a building. For example, I have a brick, I have cement. Brick, I have cement. When amine group of these things will come, what will happen? This cement will goes out. I mean to say, cobalt is a cement here, and this will goes out and causes lot of allergic reactions, that it may hamper your lungs. That is called impaired lungs. Impaired lungs means pair of lungs you have, it may damage one lung. So cutting fluid emissions to the system and surroundings. For example, you might see some of the industries are giving lot of emissions and your houses may be adjacent to it. For example, some of the industries will give you quarters, stay inside campus, and your industry is adjacent to you. So particulate matter comes, chlorinated paraffins will come, and PAH will come. So on, many things will come. So now, if you are not using the cutting fluids, for example, you are doing a machining operation of a casting. Okay, cast iron casting. So in that circumstances, what you do, lot of powder generation, lot of micro nanoparticle generation will takes place. In that circumstances, there are particulate matter. How the particles will be generated here. Okay, so there are two things. Particles will have different sizes. This is exclusively if you are using the castings of cast iron. So when you make a cast iron casting and you do the machining to get the perfect dimensions, it will generate a lot of particulates. So these particulates can be above 20 microns, above 10 microns, and below 10 microns. When these will enter into your nostrils, so what will happen? So the first and foremost is, if it is above 20 microns, it will not go into your nose. If it is around 10 microns, it can enter up to certain distance of your nose, but not into your lungs and so on. For example, if the particulate matter is approximately 2.5 microns or plus or minus slightly, if it enters into your nose or into any, it can go and occupy the lungs. So which part of the lungs? It will be occupying your alveolar region of your lungs. Alveolar region means once you breathe, you have the oxygen inside your lungs. This oxygen will be supplied to the heart for purification of the blood. In that circumstances, alvea is a micro nano passages that are there in the lungs that will supply the purest form of oxygen to the heart. So if this 2.5 microns particulates will occupy the alvea region, that means that your blood purification will be hampered. I mean to say, these 2.5 microns particles will just go and block the alvea passages. When they block the alvea passages, that means that the oxygen that you are taking inside will not be supplied to the heart. So this is another common phenomena if you are using a lot of particulate materials. At the same time, if you are working near to the casting, some of the where a lot of dust is there, of fine dust, coarse dust, and other things. So bit careful about it. So as I was saying, you residential exposures, because some of the industries will give you the accommodation inside the campus. So if you are exposed of low concentration for 9 years, nothing will happen. If you are exposing high concentration for 9 years, if you are working very close to the proximity of dangerous emissions that are happening, then you are prone to have cancer. 30 years of exposure, normally any person who joins after diploma, so he will be retired almost all 55 years, 60 years. So 20 years or 25 years you are joining and you are coming out at 60, 65 years, 50, 55 or something. So you are exposed to almost all 30 years or something. If you are bit careful about high concentrations, because you have heavy chances of getting cancer and so on. So, okay. So this is about emissions. So at the same time, these cutting fluids which are used will be dumped into the nearby water bodies. Or if there is a big industry, they dig some hole or some corner of that one and they put it. So what is happening? Depend on how you are putting, this will lead to the soil pollution. At the same time, if you are dumping into the river, so it will also causes water pollution, which I am not going to talk much on these things, because I want to talk on the system operator and adjacent operators and within the company, how to protect the operator. For example, if I want to talk outside, there is a system and surroundings. So those surroundings is a different arena. So today I just want to cover the system to how to help you. So after looking at all these things, what are my suggestions? See, as an engineer, You are the bridging between your staff, working staff, I mean to say the machinist or casting persons or something, and your management. So in a day, it is not like abracadabra change. You cannot change many things. However, you can recommend some of the safety precautions to your operator. Show them if you are not going to have these things, you see your family it as a problem. So you should wear apron, you should wear goggles, you should wear mask, you should wear all these things to take care of yourselves and take care of your family and so on. So that is a minimum requirement that one can request the management and can provide to the operator, because at last he is also a human. Okay, with this, I just would like to acknowledge all the funding agencies that supported us. IIT Guwahati about 5 lakhs, BARC about 23 lakhs, and DST about nearly 1 crore. Then DRDL about 75 lakhs. Then I got a major project about 60 crores from MITI, which is now called MITI. At the time, it is DITI, Ministry of Electronics and Information Technology. Then Imprint about 6 crores, 3 plus 3 crores. Then IIT Tirupati about 22.5, SCRP about 45. Another one SCRP recently we received is about 32. Then we have BIRAC project about 40, and we have TIH about 120. Apart from it, another 2-3 projects which are on the acceptance level, budget yet to be received. This is one side acknowledgement. On another side, the students who work day and night for upliftment of the common man, upliftment of the technologies and developing. So we also develop some of the green cutting fluids. If anybody is interested, then they can approach us. So that is another alternative solution. So which normally uses in developed nations and so on. With this, I am thankful given 1 hour. So thank you. Hello.
Participants, if you have any queries, please ask.
Sir, I am Benkappa from Vijay Technology, Shimoga.
Yeah, please, sir.
Sir, nice presentation. We have seen, normally we used to see one part of the benefits. The other part, definitely you have given a lot of information. Thanks for that. And lastly, there is green cutting fluids. So, is the invention done by, is that material available with you, sir? And what is the benefit?
So the green cutting fluids, normally we check the emissions, and these emissions are in line with the acceptable range or not. There are multiple technologies that we develop. So multiple technologies is one of the technology that we do is development of green cutting fluids. Green cutting fluids consist of lot of plant-based or biodegradable paste. Even though you breathe, not much things will happen to it. That is, we have tested on the rats and so on. The second thing is that you can also go for the minimum quantity cutting fluids. So where convective heat transfer coefficient, I think you may be aware of heat transfer and so on. So in that circumstances, you can use a minimum quantity cutting fluid. That is another area where this for example, in a normal cutting conditions, you will use 400 to 600 ml per minute basically. So that means that in the machining region, for 1 minute, normally the cutting fluid falls from the nozzle is 400 to 600 ml, which is a huge amount. So to overcome that, this may give a lot of emissions. For example, if I can reduce the cutting fluid and use the similar performance, machining performance, like that is called minimum quantity cutting fluid. There are some air nozzles basically where internal mixing of air will takes place with respect to the cutting fluid, and only 5 ml to 10 ml or 15 ml per minute will be used. Since here it is a force with high jet mist actually. So since it is not a purely a liquid, it is just a mist. Mist means like a vapor. So cool vapor. So because of that, what will happen? It can penetrate into the complex region of machining and can extract the work. That is called forced convection. It will take place. Liquid cannot penetrate in all the conditions. So these are the two technologies that one can adopt. So regarding your question, yes, we develop our own cutting fluids. If you want, you can check.
Sir, can you share this presentation with our
Sure.
Chennai chapter so that lot of information is really beautiful. I have taken a lot of photographs. But share that presentation. Thank you.
So IIF, I am very grateful to IIF because they are because no, they said one day, yes sir, this is a good area that we would like because you people are very good at casting, definitely. So when it comes to the final product, you industry has an association, or you may industry also have the machining. So they said that sir, this can be a good idea where we can pitch in for a 1 month course or something. So it is the negotiations are going on with respect to the IAF. I think just whatever I presented here is just a glimpse basically. So development of cutting fluid, development of the nozzles for the mist generation, and lot of things like you require low viscous fluids again, because if the viscosity is very high, it cannot penetrate. So the capillary action is going to take place. How the cutting fluid will penetrate, how the tool wear can be minimized. So machining and machining fluids or cutting fluids plays a crucial role to make the final product. So I pitched this one to IAF people. So they positively responded, and I think looking at the scenario or something, I think we will come up definitely in a big way.
Dr. Sir, this is Sendil Kumar here.
Yes,
Thank
sir.
you, sir.
Yes,
Thank you. We will definitely take up this, sir. In fact, internally we discussed. We will internally discuss and take it up, this, sir.
Sure, sir. Sure, sir.
Yeah. Sorry, I joined a little late. Participants, any other questions?
Sir, in the chat box, there's some small questions, sir.
Read out, Pananga.
Cast iron roughing, it will be better to machine without cutting fluid or with it, as cast iron is self-lubricating?
So normally cast iron nobody uses the cutting fluids basically, because it has a carbon in the form of graphite basically. So graphite will act as a self-lubricating material. So that's why most of the people will not use, because it has a self-lubricating properties. Okay. So my answer is you don't need to use, but you need to use mask. You need to use lot of other precautions. So if at all you want to use, you can use lean emulsions. Okay, so some of the industries will use lean emulsions because it will act as a self lubricant. But if there is a severe machining, for example, you are giving too much, for example, high speed, high depth of cut and high feed rate, in that circumstances there may be a chance of cutting tool failure or heat up of cutting fluid. So you can use lean emulsions if required, normally not required. But if the customer says my microstructure is hampering, sometimes if your temperature is very high, some of the times your microstructural variations will come onto the component. In that circumstances, to overcome that, you can use lean emulsions. Lean emulsions means instead of having 1 liter of cutting fluid with respect to 10 liters of water, you can go with 1 liter of cutting fluid with above 16 liters or 20 liters of water. So that means that your lubricating properties are minimal, but cooling properties are higher. I think I have, I think if you have still doubt, you can ask, sir, Professor.
No, sir, it's clear.
Yeah, thank you. Thank you.
Anybody is having any other questions, sir?
Sir,
Yes,
this is
sir. This is
Tanmay Shah.
Venkatagiri. Hello,
Yes,
sir.
sir. Please, sir.
Can you
Please,
hear
sir.
me,
sir,
sir?
you can ask.
This is
Please go
Venkatagiri.
ahead, sir. Please go ahead.
Yeah, this is question regarding the biocides. See, normally
Yes.
we will check this can be bacterial growth by pungent smell only. Is there any test available to check the supply for the available coolant? Currently, we will be monitoring by the time based. Say example 3 months once or 6 months once. So moving forward, the another question, second question. Is there any recycling methodology is available? Say, is anyone developed it? Rather, we are sending to the authorized vendor, or as you said that it is environmental factor which is affecting the land. Land. This one. So this is my second question.
Okay. So you rightly said, sir. Normally, in a common man language, people uses the smell based only because it will give you a strong smell. However, for example, if your cutting fluid is converting from white color, normally whenever you make the cutting fluid, it will be in white color. So whenever there is, for example, how the foreign people will handle it. So normally, if there is a slight change in the color, so immediately they will just drop it. So that is irrespective of the smell or something, because smell comes at the later the stage, as per my understanding. Okay. Second one is recycling of the used cutting fluids. You mean to say, am I right?
Yes, yes, yes. Sir.
So,
So there is a major our area of concern.
okay. So, for example, so normally, I think you may have children. Okay. So what do? You tell, for example, your son is studying engineering college. So he will eat pakoda, chicken biryani, and outside. And always your wife may be saying, "Don't eat, son, don't eat outside food." Okay. So normally, what will happen here is, so if you see that Ash will come, no, that KGF hero. I don't know full name. Ash. Yes. Yes.
Yeah,
So
yes,
he
sure.
will,
Yes, sure.
freedom oil is very good. So if you see the freedom oil is very good, or doesn't matter whether whichever sunflower oil, that is very good if you use for first time. Okay. So if you are using again and again and again, what will happen is, you have seen chlorinated paraffins and so on, these type of things. There is a concept called thermal cracking. So thermal cracking means these oils, whatever the oils that you are getting is unsaturated fatty acids, double bond and triple bonds. So when it enters into the domain of temperature, basically these unsaturated are waiting for to make saturated. That means that their bonds will break. That means that efficacy will go down. So the first time, simple example I'm just saying is, five-star hotel uses oil. I think there is one Siddhartha movie where he is a food inspector. So
Yes.
five-star hotels will come to third, three-star hotel comes to two-star to one-star. At last it will come to roadside. And you eat roadside biryani, and at last it will cause us a lot of cancer and so on, because of what is that is, it lost its efficacy basically, because it is already, these molecular chains are broken, destroyed and so on. So maybe, frankly telling, whether it is recyclable or not, I don't know, but partially we can look into that angle, because we never looked that angle actually. But in view of thermal cracking, it might have lost the efficiency of cooling and lubrication. Hope satisfied.
Yes, sir. Yes. Then again, one more question, sir, regarding the anti-foam.
Please tell me,
Yes, sir.
sir.
Yes, sir. Please.
That you said that anti-foam needs to be added in certain intervals. Is there any? See, we also facing some foam generation, which leads to overflow,
Yeah.
like type of issues we are facing.
See, the foam is a chemical basically. See, for example, if you what you do, if you are washing your clothes nowadays, nobody is washing because everybody has washing machines. But once we are children, normally we use our So a lot of foam will be generated. Foam is normally a chemical basically. So this chemical stays for a long time on to the product. So for example, you're doing a machining operation, one side workpiece will be there, on the other side, assume that rod, if the final product is coming, the final product will be coated with a foam material, which is, if you are not going to clear it. So that may hamper a chemical layer on top of it. So normally, hydrophobic silica will be used. So these are nanoparticles, but India, I don't know the people are using it or not, but you can get the hydrophobic silica nanoparticles. You can mix and you can put.
Okay.
So since the nanoparticles has high surface area, mixing should not be an issue. If you get a large particle size, then sedimentation problem will come. So bit careful about nanoparticles. Don't get the microparticles or something, because nanoparticles means you can, because surface area is more, so sedimentation problem will not be there.
Okay, sir. Thank you.
Thank you, sir. Any other questions, gentlemen?
Sir, this is Tanmay Shah here.
Yeah, please, sir.
Which company, sir?
I'm from Shah Prasikas, Sangli, Maharashtra.
Okay, go ahead, sir.
Yeah, I have two questions. One is, as per the foundry norms, we all foundrymen tend to test our material whichever is received, be it scrap or be it any sand or paint. So is there any way to test any cutting fluid? And if yes, then by what means and what can be adjusted from that test?
So the first you can do is TGA, thermogravimetric analysis. So there is a equipment called TGA, where on one side you are placing your liquid on a micro balance and you try to give the heat to it. So at what temperature, what compounds are coming out, it will tell you. Because since you are heating, so what will happen? This will start evaporating. Am I right? Once it start evaporating, on the top you have lot of detectors. So detectors will give you at what temperature, what emission is coming out. Hope that serves your purpose, I think.
Okay. And the second question, your subject topic that was cutting fluids in machining of castings, Boon or Bane. The first few slides, they were tilting towards the Boon, but after the initial first slides, all the disadvantages started that you had uh, put forth in front of us in form of the skin related problems. So I could not resist but think that whether really it's a Boon or Bane. So do you mean to say that we have there has been an development to replace the cutting fluid for the machining?
See, sir, the people want dry machining only. Okay. See, dry machining is the best machining operation but for that purpose, India cannot offer that, because no, you have to use PCBN tools and so on. In America, in Germany, in Japan, they don't look at the money aspects. So they look at the environmental aspects, so on. For example, if you take a small example, so there is a asbestosis company in America, basically MNC. Asbestos, asbestos sheets normally will be manufactured. So these are all as per the customer requirement. They used to cut into sheets and load and just to transfer. So how do they cut? They cut by slit saw, which is look like a saw cutting. I mean to say circular slit saw. So whenever you have a lot of mechanical action slit saw, what will happen? Asbestos sheet will generate a lot of dust particles into the air, which hampers the operator. At the same time, this will hamper the surroundings also, because particulate matter in the vicinity of the company will be very, very high. In that circumstances, they gave a warning. I showed, the first one, International Agency for Sustainable and Cancer and so on. So they have given a warning, but still they have not realized. After 3 months, they just went and In America, that's what I'm saying. They just went and locked the MNC. You know, a company locked down by a government is a big issue. So then after 6 months to 8 months, they came up with a technology. Okay, where this dust particle, we see no company avoids the dust particles, but government also don't says that you have to avoid 100%. They say that the permissible limits are there. So within the permissible limits, they came up with a technology. I don't know how many of you know the technology. It is a common technology only. So the technology is called water jet cutting. Okay, many of you know water jet cutting nowadays. So when water jet cutting comes, what will happen? This water jet cutting cuts the asbestos sheets at the same time. It will also catch the dust particles which are going up, so that some particles will go which are with the permissible limits. So like that. So what I mean to say is that everything has two coins. So you have to use the cutting fluid, but it is as an engineer, you should protect him by giving the basic amenities and facilities and so on. So if that is the case, that is a boon. If you are not giving, that is a bane. So such technologies we have. For example, we have another technology, for example, castings. So there are internal regions which one cannot access to machine, or internal access, for example, cooling channels and so on. In 3D printing, normally cooling channels and so on. For example, let me show you. Where is the component? So this is a 3D printing component actually. So this has a hole here and there is another hole here. So how to polish inside? Because this is a very tricky. This has to go here and it has to come here. So another component is, there is another component here. Okay, so it is not visible here. So what I mean to say is that this is very difficult. Such critical situations will be there in casting also. So we have liquid based cutting tools, liquid or semi-solid based. It is not like a lapping fluid or something. Polymer networks that will hold the abrasive particles and flow from here to here. Those are called viscoelastic fluids. These viscoelastic fluids also we develop, and this normally currently we are selling to the 3D printing industries, and those casting industries, if they are looking at, we can have a technical presentation, because sometimes you may be require those things.
Sir, interesting. Gentlemen, any other questions?
Yeah, you can see this component also. This is another component, very tiny component. I don't know how many of you are able to see. The fluid has to flow from here. It has to be polished from, it has to come out here and it has to come out here and here. So this has to be polished inside. Okay, this hole, through this hole, this is very complicated. And this is, the hole size here is, for example, if you see here, there is a small hole is there, which has to polish and come out. Here it is a 4 mm hole, here it is a 1 mm hole. So this type of tricky solutions required in India. That's what is where India is lacking, is micro nano manufacturing and sustainable manufacturing. So that is a very big area, and casting industries may require some of the solutions of these things. So we are very happy. I think sir, as we have discussed in when we have a MOU at IIT Tirupati, and we will come up if there is an interest and people are coming forward. So we definitely leverage our technologies, how this can be beneficial for you.
Yes, sir. This is our starting point. I think for started, so giving information to the members, I think it will spread, and we will definitely come back to you, sir. Members, any other questions? Gentlemen, if there is no questions, shall we go for a vote of thanks? Okay. Thank you, Dr. Sir, Mamilla Ravi Sankar sir. It's indeed wonderful and fantastic topic, and I think it is very new to our foundry fraternity. And the day we met and you talked about it, we were very keen, but due to some time pressure, we were not able to do it immediately. First of all, I would like to thank you for accepting our invitation and spending your valuable time in your busy schedule. Thank you very much, sir. And I'm sure that the participants who have participated across the nation has taken a lot of takeaway from this presentation. As Doctor said, they got a lot of green cutting fluids and a lot of other new technologies. And whoever members are interested, you can reach us Chennai chapter, and we will be able to connect with them. And the topic is indeed very interesting. And then it is also talked about how it is affects human being. So nowadays the EHS is coming up in a big way, and we have to see that other side of it also. A lot of importance has to be given, and I'm sure that we understand that point of it. I'm also thanking for all the members who have joined for this meeting. And as you all know, that Chennai chapter is having our dedicated YouTube channel, and all these programs are getting hosted. And we want requesting you to check the YouTube channel and subscribe that. And we from Chennai chapter conducting regular programs through online and direct, and we request your continuous support. Thank you very much once again for all your participation. We'll meet in our next technical program. Thank you very much, sir. Doctor, sir, thank you very much.
Thank you, Andy.
Thank you, sir. Thank you.